Hey guys! In the previous video, we learned what is a calorimeter and what is the calorimetry process in order to calculate the energy involved in a physical or a chemical reaction. In today's video, we're going to do an application problem of calorimetry. Let's read the question first. Aqueous copper 2 sulfate reacts with sodium hydroxide in a double displacement reaction. A precipitate of copper 2 hydroxide and aqueous sodium sulfate is produced as shown in the following reaction. So this is our reaction. So these are the two reactants and these are the two products. A 50 ml volume of 0.300 moles per liter copper sulfate. So we are given copper sulfate volume and concentration is mixed with 50 ml of NaOH solution that contains an excess of NaOH. So we are given the volume of NaOH. But since we're given that NaOH is in excess, we do not have to worry about its concentration. Because we're given an excess of NaOH, so we do not have to worry about what is the concentration of NaOH. The next part of the question says that the initial temperature of both of these solutions is given to us as 21.40 degrees Celsius. After mixing the solutions in a simple calorimeter, the highest temperature reached is this. Determine the enthalpy change for the reaction as written and write the reaction's thermochemical equation. Since we know we have a simple calorimeter, so let's say this is how the simple calorimeter look like. There is water inside the calorimeter, and apart from that we put in this mixture. So copper sulfate and 2 NaOH. Because this is aqueous, that means these are already dissolved in water. So basically there is water, copper sulfate and sodium hydroxide inside this calorimeter. And as we know, the water part of the calorimeter behaves as surroundings. This part is going to behave as a system. So this whole reaction is going to work as a system reaction. So when these two ingredients or when these two reactants are mixed together, a reaction is going to take place, which is going to give this as a product, and this product is going to be solid. This product is again aqueous. So this is what we are going to see at the bottom as a solid substance. But because there is a thermometer in this calorimeter, we measure the initial temperature of this solution when we just put in these reactants into it, and that was the initial temperature, 21.4 degrees Celsius. Final temperature after we give some time to this mixture to react, and the highest temperature that was recorded was 24.6 degrees Celsius. We can use this to find out the delta T value, and that is Tf minus Ti. So this is 24.6 minus 21.40, which is 3.2 degrees Celsius. So this part of the question is not solved yet, but we have actually found out our given. Because we know calorimetry problems involve the use of Q is equal to MC delta T formula. So this is that part of the formula that has been obtained. And also we know that Q is equal to MC delta T is for Q of surroundings is equal to M of surroundings times C of surroundings times delta T of surroundings. And here we see that surroundings is always in a calorimeter water. Mass is something that we need to determine. Delta T of surroundings or delta T of water is this 3.2 degrees. C of water is going to be 4.19. So this is degrees Celsius. This is joules per gram degrees Celsius. Now we need to know this mass in grams. For that, we'll go back to the question and see where are we given the mass. Now in order to determine the mass of water, we are not given anywhere the mass of water or even the volume of water. But we remember one assumption that in a calorimeter, no matter what you mix with calorimeter, it will not change the properties of water. And one of the important properties of water is that the density of water is always 1 gram per ml. So whatever is the volume of water, the same will be the mass of water, because density is equal to mass over volume. Because this is 1, therefore we can say mass of water is same as the volume of water. Now since we are mixing 50 ml of copper sulfate, and this is an aqueous solution, that means mixed in water, and this is also 50 ml of NaOH solution, that is also an aqueous solution mixed with water. So if we add both of these two volumes, we will get the total volume of water that is inside this calorimeter. So from here we get to know that volume of the calorimeter is volume of copper sulfate and volume of sodium hydroxide. Now volume of copper sulfate is nothing but 50 ml, and similarly volume of sodium hydroxide is given to us as 50 ml. Total is 100 ml. This is the volume of solution, or we can say this is the volume of water. And we know volume of water is same as the mass of water. So mass is now going to be 100 grams. All we have to do is just put that 100 here. Grams get cancelled. Degree Celsius gets cancelled. We put everything in the calculator and we'll be able to get 1341 joules. This is all the work for finding out our given stuff. Now, since we got Q water, are we looking for water Q? No. The question wants us to find out enthalpy change for the reaction, and reaction is the system. So delta H of system is negative Q of surroundings, which is negative 1341 joules. So this part of the question is done. We already have the enthalpy change. Now we have to write down the reaction thermochemical equation. That means we have to put in that small delta H value here. Now, in order to put that delta H value, we look at the number of moles. So the number of moles here we are given is 1 mole of copper sulfate, and we are given 2 moles of sodium hydroxide. We do not have to worry about what is the moles of sodium hydroxide because sodium hydroxide is given to us in excess. You must have done this in stoichiometric calculations in previous grade, maybe grade 11, where they just tell you that if any reactant is present in excess, we do not have to worry about its moles. We only have to worry about the moles of the reactant that is limiting the reaction. In this reaction, this has 1 mole because that is a limiting amount of moles. We need to make sure that this delta H is for 1 mole of copper sulfate. Are we given 1 mole of copper sulfate in the question? We were given 0.300 moles per liter of copper sulfate. So we need to find out how many moles of copper sulfate are present in 50 ml copper sulfate solution if we have put in 0.300 moles per liter concentration of copper sulfate in there. And I hope you remember this formula from previous grades. Number of moles is concentration multiplied by volume. Concentration is given to us as 0.300. Volume is given to us as 50 ml. Because this is moles per liter, concentration is given to us as 0.300 moles per liter. Volume is given to us as 50 ml. In order to calculate the number of moles, we need this liters to get cancelled out with liters. So how do we change this to liters is, we divide this by 1000 ml that is contained in 1 liter solution. So now we can cancel milliliter with milliliter, cancel 0 with this. Put this on the calculator, liters and liters will get cancelled out, and the unit that we'll be left with is going to be moles. 0.300 multiplied by 5 divided by 100 gives us 0.0150 moles. Now all we have to do is get our delta HR, and we know from the previous videos that delta HR is delta H divided by the number of moles. Delta H that we have found out is negative 1341 divided by number of moles we have just found out is 0.0150. We put this on the calculator and we get, now since this is in joules and this is moles, we get negative 89400 joules per mole. If we want to make it smaller, we can divide it by 1000 and we can get negative 89.4 kilojoules per mole. And now we can use this delta HR value to write it along with the reaction. So our final reaction is copper sulfate, and that was aqueous, plus 2 sodium hydroxide, also aqueous, gives us copper hydroxide solid plus 2 sodium sulfate aqueous plus 89.4 kilojoules. Now, because it's negative, that's the reason we are adding it on the right side. And since we know how to represent a thermochemical equation, this is one of the ways of representing the thermochemical equation, that is exothermic.